Good evening, ladies and gentlemen, distinguished guests, and what an amazing audience you've been. You've been very patient so far. Um, what I'll try and do is continue your learning journey. I guess you're here to learn for these couple of days, um, and try and bring another perspective to one of the topics which were there in your agenda, which is how to look for readiness when it comes to AI/ML for government and for citizen services. So if I can move to the presentation, there you go. So how do you define readiness, right? So one of the keywords in my presentation is future-proof, and I've tried to define it here. Instead of reading the whole text, I think if you just look at one word here, which is obsolescence, I think we are all worried about obsolescence, right? We don't want to want our smartphone that we purchase today to be obsolete tomorrow. And the way we do that is by updating the apps, updating the operating system. But I think the important thing that we need to understand is obsolescence is built in because the pace of expectation of technology from consumers is just sky high, right? And we are all consumers. And guess who's responsible for that pace of expectation from technology? Technology builders like Amazon, right? We shop at Amazon, we use a whole bunch of Amazon products. So over the next few slides, what I will try and do is alternate between how Amazon, the company, is innovating on technology and increasing the pace of innovation or the pace of expectation from technology, and how AWS, the Amazon Web Services, the cloud that we've learned to use, how that is transferring that pace of innovation to the customers in the form of services, and how some of our customers are informing not only how AWS is used, but also some of the features that other customers get to use. And all of this is wrapped around some of the programs that we run, Educate being one of those programs. And I'll just pause for a second as you read this testimonial of how cloud skill building is going to transform our society over the next several years. And we are already taking some huge steps in that direction. But let's talk about that pace of expectation from technology, right? This is a familiar web page. You go to Amazon.com or Amazon.in and you select a product. You're selecting a product amongst hundreds of millions of SKUs. I'm so sorry. And you're one of the hundreds of millions of users who visit Amazon websites. And almost in near real time, what you're getting is product recommendations at the bottom using machine learning technology. And how are our customers using at AWS, how customers use these recommendation technologies? Coursera is one of the leading online learning platforms. So if I have an account in Coursera, and because my interest is in machine learning, I'm recommended courses based on my interest. Again, using machine learning as the technology behind the scenes, done at huge scale. Most of you would have used some sort of digital video or online digital entertainment platform like Netflix, Amazon Prime Video. This is Amazon Prime Video. I have the movie Rock On, one of my favorite movies, on Prime Video right now. And as I pause at a scene, which is quite a hazy scene, you can't make out what's going on in this scene. If you notice on the left-hand side, I have a drop-down which is called X-ray. So it is not only telling me who are the actors in that scene, but it's also telling me behind the scenes which is the music band which is providing the music. And this can happen across hundreds of thousands of hours of video footage using, again, machine learning technology, what we call content exploration technology. And if you look at one of our customers' websites, one of AWS customers' websites, called Wolfram Alpha, you can type in a query like, what's the correlation between the GDP of India and the population of India? You'll get back results, not just in the form of a set of graphs and analytics, but also data points. And all this using natural language queries. Wolfram Alpha runs on AWS Cloud, and uses machine learning frameworks like MXNet. Human-centered technology. You've all heard of Alexa. You say, hey Alexa, what's the weather today? And Alexa comes back to you with a response. And that particular technology is not only powering a whole bunch of customer products, but also our own products within Amazon. Amazon Rapids, what it does for kids is it takes textbook comics, which are written in text, and converts it using voice acting, completely using digital. So there are no human voice actors. It uses machine learning to convert text to speech. And I have an example, if the audio hopefully plays, here for you. So this is the Amazon Web Services Cloud Console, okay? There are a number of pre-built demos which are part of the AWS Cloud Console. So there's an empty text box here, and the service that I am demonstrating here is called Polly. It is our text-to-speech service. So what I did for this particular demo, I took randomly, I took what I could find as the most Shuddh Hindi that I could see online, and I went to the Government of India website, and I copied a piece of text. So,
किसी भी वाक्य को पढ़ सकती हूँ। भारत एक प्रभुसत्ता संपन्न, समाजवादी, धर्मनिरपेक्ष, लोकतांत्रिक गणतंत्र सहित एक संसदीय प्रणाली की सरकार वाला देश है। इस खंड में पाठकों को भारत की सरकार, इसके उद्भव और देश में अपनाई जा रही सरकारी
So I'll pause there and I'll come back to the previous slide so that we don't repeat the audio. But what you just heard was almost in near real time conversion of Hindi text. Any text that you copy from the web or you type in Hindi or English and in multiple languages, converted to human-like speech automatically by a computer, by the cloud technology. Again, using machine learning, natural language processing and machine learning.
Namaste.
Sorry about that. And what you can do with that is you can combine that voice to text or text to speech engine with another technology of AWS Cloud, which is Sumerian, which allows you to build virtual reality and 3D experiences. So you must have seen those VR goggles, right? The content created for those VR goggles takes teams to develop in traditional ways. But now you, your kids, your friends and family could actually launch Sumerian, go through some 50-odd tutorials that we have. You probably need to go through about 5 of them with very limited or zero 3D design experience. You could actually design experiences like these by just dragging and dropping avatars like the one you see here. And not only that, if you're interested in experimenting with deep learning, then you can use cameras like Deep Lens, and you can actually run computer vision applications on this. So how is all this technology coming together? How is it helping citizen services? Here's one example of it, which is recognition technology being used to reunite missing children. And just to summarize in terms of Amazon use of technology when it comes to machine learning and AI, this is just a subset of machine learning technology that Amazon, the company, uses. And I've just spoken about 2, the ones highlighted in blue. And this is just a subset. But what we are doing is we're providing a lot of this technology as part of Amazon Web Services. So these are the various services that are available through AWS Cloud. I'll expand on the machine learning side of the services, where we are providing tools which allow you to build machine learning models, train machine learning models, and of course deploy them for applications that you saw earlier. So what I'm going to do over the next minute or 2, and try and stick to the time that's been allotted to me, is actually build an application, a future-proof citizen services application in front of you, right, in 3 steps. Okay? So bear with me. What does a future-proof machine learning or citizen services application comprise of? It's 4 steps. You build a minimum viable citizen services application and put it out there for your users to use. In fact, this is how Amazon builds a number of its own products. AWS builds a number of its own services. Once you provide that product to your users, you start generating data. You extract that data, bring that data into your data lake. We heard about data lake earlier, and you measure what's going on, how is my user using it. And then you learn from it, and you further improve that product, right? So what we're going to build is an application which is, think of this as a virtual reality experience. So you actually walk up to a kiosk, and you select the presenter that you want to listen to, and the presenter comes up at the bottom right there. And then you go through the content with that presenter, you learn, you interact, you actually voice over. You're not just listening, you're interacting with the presenter, you're asking questions, you're responding to answers. And the content that you're getting back is changing adaptively based on your interaction with the presenter. Wouldn't that be cool, right? How do you build that? First step, just two things. Use Sumerian, which you saw earlier, and use Lex, which is our chatbot technology, and the build phase is over. Okay? Guess what? You just do drag and drop. You use step-by-step tutorials that I talked about. It's console-based configuration, like I had shown you earlier. Reuse AWS design 3D models, minimum 3D design experience required, and zero programming required to build that experience that you just saw. Next, you bring all that data into a data lake. 4 steps to get into a data lake. I won't explain each of the components. These are all services that AWS Cloud provides. But what's important is to just understand what's happening here. This is what is going to run the entire analytics pipeline. And guess what? Again, drag and drop, console-based configuration, structured query language available to you, no database required. Normally, you associate structured query language with a database. There is no database here. Okay? Next, what you're going to do is you're going to run machine learning. Okay? And the interesting thing here is services like Transcribe and Comprehend and Poly, you don't have to build any machine learning models. Amazon is doing that for you. AWS is doing that for you. So when you want to actually build custom machine learning models, that's when you use service like SageMaker. So fewer machine learning models that you need to use. You can use API-based services and again, console-based demos like you saw the Poly example. Okay? What does that mean? What that means for you is you never pay for idle time when you're using these services because they're all serverless. So effectively, there are no servers required in this entire architecture diagram. Right? So you don't need to worry about data centers, you don't need to worry about servers, you don't need to worry about provisioning, you don't need to worry about fault tolerance, scalability, you just build what your citizens need, right? So I'll just summarize from the iron age of data centers moving to virtualized data centers, moving to cloud, now you have serverless, and what serverless does is it actually improves your operational efficiency, increases productivity, and of course, better time to value. So in summary, how do you future-proof citizen services? You move from before to current to future-proof, use multi-sensory user experience instead of touch and gesture alone, build intelligent applications using the APIs that we saw earlier, Poly, Comprehend, and so on. Instead of data warehouse, go data lake, 4 steps, and you have a data lake ready on AWS Cloud. Use serverless technology like we spoke about, and that in turn means outcome-based value for you, because serverless is completely outcome-based. It's literally like turning on the tap or turning on your air conditioning. You don't pay for the number of ACs at your home. You pay for the amount of time that your air conditioning is used. With that, I'll thank you all once again for being a very patient audience.